looks like fun. So that's 5 times the 4th root of 32 plus 3 times the 4th root of 162. None of those are exponents. We're okay with that? None of those are exponents? I'll get rid of these. So you need to break these down. So what did you do to try to break these down? Those are nouns. Can you give me a verb? What did you do? 5 times, yes. So these right here are coefficients right here. 5 and 3. Those are coefficients, okay? So if I want to put parentheses, how about that? Is that good?
Yeah.
So what should you do? Give me a verb.
Factor.
Factor. I like that. Make a factor tree. You want to factor these things. So 32 is nice because it's 2, 2, 2, 2, and there's 5 of them, right? But it's 4th root, so how many are you looking to pull out? 4 of them. So what's the coefficient going to become on the outside? So it's going to be 10 times 4 root what? 2. Because one of those 2's is left. What about 162? What could you pull out first? I'd pull out 2, and what are you left with? 81. But what is 81? 3, 3, 3, and 3. So what can you pull out of that? 3. So what's the coefficient become? 9 times the 4th root of 2. And that's a terrible way to write 4th root. So now can you combine them? So how many do you have? Now you have 19 times the 4th root of 2. Again, I'm being really terrible with my writing of these roots. I'm sorry. I'll try to do better. Why this is, so if we're simplifying this right here, the 4th root of 162, and again, I'm doing even worse at writing my radicals. The 4th root of 162, that's the 4th root of 2 times the 4th root of 81. What is the 4th root of 81, Summer? 3. So you end up with, there's already a 3 on the outside. So what's 3 times 3? 9. That's where it comes from. Not super, super easy, but you should attack it like you would any other question. No, the rules don't change. What does 4th root mean? What power is that? Yes. 2m to the 9th, not p, it's p, sorry. P to the 6th to the 1/4 minus 3m squared p times mp squared to the what power? 1/4. What can you do with that 1/4 power? Distribute the power. Are we okay so far? I haven't done any multiplication. All I've done is rewrite. I went from radical form to exponential form. So I can distribute. So it becomes 2 times m to the what power? 9/4 p to the... What is 6/4? Simplify for me. 3/2 minus 3m squared p, m to the what power? 1/4 p to the... a half. 2/4 is a half. Exactly. We now can combine something here. There's m's there and p's there. What do you do with the powers? You add them. What's 2 plus 1/4? What's 2 plus 1/4? Write that in fraction form. 9/4. P, it's 1 1/2, so what's that simplify to? 3/2. Look, kids. I'm telling you right here. What's 2 plus 1/4? 9/2, right? What is 1 plus 1/2? 3/2. So now what do we actually have? 2 of them minus 3 of them, so what do you end up with? Negative m to the 9/4 p to the... Oh, look at that. It worked out. That's kind of cool.
Will there ever be a situation where we have to factor using variables?
Yes, absolutely. We've done that. We've already done that in
Yeah,
this
I know,
class.
but like I just like...
Yes, it will happen. This one worked out nicer than I thought it would. I thought we were going to have to factor something out. You don't. Okay, so on this one right here, can you just add them? Do you have the exact same thing? No, you don't. So what's your cube root? What is? Can you simplify anything, though? Is there anything you could simplify? Yeah, what's the cube root of 27? So this one you can. Just take the easy, right? So this is the cube root of m to the 5th over what? 3 minus 2m times the cube root of m squared all over 4. Hey, what happens with the 3 and the 3? They cancel. So take what you can get. You get cube root of m to the 5th minus, and this cancels, leaving you with what? 2 and 4. What does that simplify to? No. What does 2/4 simplify to, kids? 1/2. So I'm saying this goes away and this becomes a 2. So you end up with m/2 times the cube root of m squared. What is 2 divided by 4? 1/2. 1/2. But there's an m still there. That's still there.
So we put the m
It's on top.
in the
Yeah.
fraction.
It is. Oh yeah, because it's being multiplied. Yes. Because what's the denominator here? 1, right? 2m over 1. We're not done yet though. We'd like to combine these, but the thing is, are these exactly the same? They are not. They are not exactly the same. What power is cube root?
I would put that over the 2.
You can. It's the same exact thing. What is cube root? What power is it? 1/3. Do you realize that 1/3 and third not the same thing?
Yes.
Just checking. Okay. 5 over 3 minus 1/2. What power of m is right there? 1, m to the first. And what power is that one going to be right here? M to the what? 2 over 3. You with me so far?
Yeah, why just change that?
Because I'm about to do this. You have m to the first times m to the 2/3. What do you do with the powers? You add them. What is 2/3 plus 1 equal to? What?
1 and 2/3.
Write it as improper fraction for me. How many thirds? 5/3. 1 and 2/3 is 5/3. Oh, look at that. Do we now have the same exact thing? We have one of them and we subtract 1/2 of them, so how many are left? 1/2 m to the...
5/3.
All done. Does 4 have a nice cube root? No. Does 9 have a nice cube root? It does? That's a nice square root, not cube root. So what does cube root mean? What power is that? 1/3, exactly. So that's 4 to the 1/3 over t to the 9th to the plus 3 times 9 to the 1/3 over t to the 12th to the 1/3. What do you do with powers of powers, everybody? Specifically right here, what do you do with those? You multiply, and those actually kind of multiply nicely, right? So what do you end up with? Negative 4 to the over t to the what? 3rd. Yep. Plus 3 times 9 to the 1/3. Oh, I can almost write a third, almost, but not totally. 9 to the 1/3, and let's stay black. Over t to the what? 4th. So let's zoom in here. We're not quite done yet. We'd like to do some more. One thing you might notice at this point, just it might help you out. You're almost to the same thing. That might help. So at this point, what do you think the only thing you really can do is? You asked me about this before, Aubrey. You just asked me about this. Might we have to what?
Take out.
We have to factor.
Yeah.
Factor. So what can we factor out of both of these? So, not t. Close. What could you factor out? Where is t? Is t in the numerator or the denominator? So what can you take out? 1 over t. But you can take out more than that. 1 over t to the 3rd. 1 over, well, you have to be, there's no 3 right here is the problem. So 1 over what? T to the 3rd. What does it become? Negative 4 times 4 to the 1/3 plus 3 times 9 to the 1/3 all over what? What's left? T. I need you to pause right here. Do you now end up with 1 over t cubed times negative 4 to the 4/3 times 3 to the what? 2/3 all over t.
Wait, I have a question.
Yep.
Oh, where did the
Badness. There you go. Plus, no, it's really important. Changes everything, right? Totally changes it. You're like, I don't know how he did that. I kind of want to know how you do that. Okay, we can combine that 3 to the 1st and 3 to the 2/3. What do you do with them? Yeah, so you end up with 1 over t cubed times negative 4 to the 4/3 plus 3 to the what? 5/3 all over t. And the only thing I would do to change this, I would do this. I would make it 3 to the 5/3 over t minus 4 to the 4/3. That's what I would do. And this is what I would say is the final. This one's a lot of work. What do you need to do? Distribute. So root 5 times root 6. What's that? 30. What's root 5 times 1? Root 5. What's 3 times root 6? No. What's 3 times 1?
3.
You're done.
That's it?
Yes. So how many people got that or something very close to that? Nope.
Milo.
All kids. All we did was FOIL. The thing is, if we could simplify this, we would. Here's the thing. Is there anything we can do to this besides factoring, which gets us back to originally what we started with? No. There's no way to really combine these, right? If you start forcing it, you're going to end up back where you started. Let's try the other one. Let's try the other one. Same system, FOIL. First out or inner last. Nick, what's 7 times root 5?
7.
Yeah. What's 7 times root 2? Nick is there. Whoever over there is over there. What's negative root 3 times root 5?
Negative square root of 15.
Yes. And what's negative root 3 times root 2? Done. Negative square root of 6. Sometimes you will be able to simplify. In this case, can you simplify either of these? No. There's nothing to be done. There's nothing to be done on these. Are there others, though, where you might have to simplify? What's root 10 times root 10?
10.
Is 10. And then you get minus 3 root 3 root 10 plus root 3 root 10 minus 3. What happens to the middle terms? And you're left with 7. So try D. D is not going to be quite as nice, but it'll be nicer than the first ones we did. You got 16 minus what?
6 square root 7.
Let's try it. So this means root 7 minus 3 times root 7 minus 3, right? Root 7 times root 7 is what? 7. And then you get minus 3 root 7 minus 3 root 7 plus what?
9.
Plus 9, because negative 3 times negative 3 is 9. Oh, 7 and 9 is? So you do end up with 16 minus 6 root 7. Very good. Aluminum siding into this. So kids, how about you try this one? Simplify that for me. Simplify that one. Okay, what's the square root of k times the square root of k? K. And then you get minus root k, like that, plus root y root k minus y. What cancels in the middle? So you get k minus y. Oh, does that kind of fit one of the answers we already did?
Yeah.
It fits this one, right?
Yes.
Oh, look at that. Look at this one. When we did this one, we did root 10. Look at that. What's 10 minus 3? It does fit. It does fit what we did is what I'm saying. There is something about it, though, that you, in other circumstances, and in this class, will not want to have. That is having a radical in the denominator. There are times when you really do not want a radical in the denominator. The phrase for what we're doing is called rationalizing the denominator. We're turning root 7. What type of number is root 7? Root 7 is what type of number? Irrational. So we're going to take this fraction, not change its overall value, but rationalize, meaning make the denominator rational. What's the only thing we're allowed to multiply by and not change? 1. Any form of 1. What's something we could multiply root 7 by to get not an irrational number? Anybody want to take a guess? Root 7. But if we multiply the denominator by root 7, what do we have to multiply the numerator by? Because this right here is just a fancy form of
1.
So we end up with 3 root 7 over what? 7. Because root 7 times root 7 is 7. What we've shown is that 3 over root 7 is equal to 3 root 7 over 7. These are the same, but here's the thing. This one has an irrational denominator. This one has a rational. We have now rationalized the denominator. All we've done is we've multiplied by a fancy form of 1. You're just going to do this same mechanism many.
And then square root 5. Yeah, root 5.
So what do you end up with? 5 root 10 over
5.
cancels, and you're left with root 10. Harry, shh. This one, though, you have to do a little bit of simplification first. What does that negative sign do? It's nothing. Just stays on the outside, right? But this is the same thing as the square root of 9 times the square root of 3. Or no, not 3, what? 2. And this is the square root of 25 times the square root of 5, right? Because what's 9 times 2?
3.
What is 9 times 2? I got a really quizzical, strange answer out of you. What is 9? 55? What's 25 times 5? But why did I do that? What are these? They're really nice, right? So what do you have here? You have minus root 2 over root 5, 3 root 2 over 5 root 5, right? Is the denominator rational or irrational? It's irrational because if you multiply a rational times an irrational, you get an irrational. What do we need to multiply by? Over root 5, and what do we end up with? Negative 3 root what? 10 over 5 times 5, which is 25. So you get 3 root 10 over, done. The exponent is 1/2. So we have 50 m to the 4th over p to the 5th, all raised to the... What do you do with those powers of powers? You... Powers of powers, you multiply them. You like that? I'm going to be a air traffic controller. It's going to be 50 m to the 2nd over p to the what? 5/2. This is where it gets kind of fun because what does 5/2 power mean? What does 5/2 power mean? It's the square root of p to the 5th. That's not rational, or not necessarily. We would like it to just be a number, right? This is where it gets a little bit interesting because we'd like it to just be like p to a number, namely 1. We'd love it to be p to the 1st power. So the question I have for you is, we're going to multiply by something, right? And it has to be the same thing on the numerator and the denominator. What do you multiply by to make that p to the 1st? This is challenging. Choose p to the negative 3/2.
Because when you're multiplying powers, it's addition. So if you add negative 3/2 to 5/2,
Yeah.
it's just
What is 5/2 plus negative 3/2? 2 over 2. So what does it become?
1.
1. It just becomes what?
1.
1. Exactly. So what does this become? It becomes 50 to the 1/2 m squared p to the what? Negative 3/2 all over what?
1 p.
P to the 2 over 2, right? But what is 2 over 2?
1.
So it's p to the 1st. That right there, you've just rationalized the denominator. Is the numerator terrible?
Yes.
Yes. But our only goal was to rationalize the denominator. If p is an integer, is this rational? Yeah, it is rational. We have rationalized. We have made the irrational denominator now rational. Do we care what the numerator looks like? This is kind of a cop-out too, because what does p to the negative 3 over 2 mean? 1 over, right? So if you simplify this, you drop it down. Don't.
Yeah.
This has a rational denominator. That's all we were interested in right now. Right now, that's the only thing we were interested in. Yes.
Do you have to write the numbers?
No, you could just write it as p. That's fine.
Wait, how do you get that?
Later, when we have imaginary numbers, and it's doing the crazy thing, I'm sorry. And I really have to turn that off so you don't go crazy, right?